Hey guys, let's do it. Lesson check 11.2. So question 1 says, which best compares the volume of cylinder X and cylinder Y? So we talked about this would be a bunch of stacked up quarters that you get from the bank. You can see all the edges of the corners there, you know. Think of the ridges on the quarters. And then what if the stack got pushed over a little bit? We should recognize here that as long as it has the same height, which it would, as long as it still has the same radius and all that, these should be equivalent, equal in volume, equal volume. This is what's known as Cavallari's principle. Okay, question number 2. Alice is shopping for cheese. So the volume of anything in the universe is the area of the base, and we know the base is the same as that height here, even though the base is hidden, right? The area of the base. So that's length times width, right? And then however high, we stack that square or rectangle, right? So it looks like we stacked it 10. So base times width times height. So 3 times 4 times 10. Now it says a piece of brie. So I guess this is my cheddar. The brie have the same volume, even though their shapes are different. What would be the width of the brie? So these are supposed to have the same volume. So the volume of this object, or the volume in anything, is the area of the base, and our base would be that same shape. So base is a triangle, so that's 1/2 base times altitude. Boo, splat, right? So base is W, altitude, so 1/2 base times altitude. And then however high you stacked those triangles, and it looks like you stacked them 10 high. So the volume of this object is the area of its base times its height. So let's plug in what they've given us. We know the volume is the same. They said they had the same volume, so we can plug in 120. The base here is W. The altitude is 3. The height is 10. So using a lot of Lin-Schop, right, the 2 can go up there. We have W times 3 times 10, that'd be 30. Okay, so the left side, I now have 240, and I have 30 W's, so we can divide by 30 on both sides, and we get 8. And that makes sense. That's one of our choices. So we can plug in 8 and double check our answer. Would 1/2, 3 times 8 times 10 equal 120? Yes. So those have the same volume, 120 centimeters cubed. Now, question number 3. Jeff is making a jar of jam mailing it to his grandma. How sweet. So we notice that there's some space around this jar, right? And that's actually what they want us to find out. What is the volume that's not occupied by the jar? So using this logic, we want the area of the whole thing, the whole box, take away my jar, and that should be the space left over. So the whole thing is a box. So what is the volume of my box? Well, the volume of anything in the universe is the area of the base, right? And so even though we can't see the base, it matches the lid. And what is that? So that'd be base times width. And then however high you stacked that rectangle. This looks like we stacked it with an H. So the area is base times width times height. Now, what is the area of my cylinder? That's a cylinder, right? It's the same thing. The area of my base, and that's a circle, right? So what is the area of my base? Well, it has a radius of 5. So the area of my base is pi r squared. So pi times, I guess r squared, times however high I stacked these circles. Well, I stacked them the same height, the height of h. So this is the area formula for a cylinder. Okay, now we can use this to find the space left over. So what is my base? It looks like 15. And what is my width? 10. And then I'm supposed to leave height h. So that'd be 150h. And then I got pi, and I know my radius is 5. So pi times 5 times 5 times h. So minus 25 pi h. Now, it looks like, yeah, these two look an awful lot like it. It looks like this first one, they factored out an h. So let's do that. Notice I have an h in both terms. So if I factor out an h, I have my answer, C. That matches my answer. Cool. All right, question number 4. A stack of saw blades fits snugly in the carton. So you can imagine all these little saw blades in here to keep people from cutting themselves. The saw blades, 16 of these would stack in here. So they must be very, very, very thin, right? Because 16 of them fit into this box. What is the thickness of one blade? Round to the nearest 3 decimal place. Okay, so what do we have here? Well, let's see. If this thing fits in there, that means all the way across is 12 and halfway is this. So this has to be a radius of 6. So the volume of anything in the universe is the area of the base, and the base and the lid are the same. So the area, pi r squared, is my circle, and however high I stacked it. So I'm just going to call that h. Now, interestingly, I know the volume of the carton, that's 226, and pi, I know my radius, so 6 times 6, and I can solve for this height. Okay, now they didn't ask for it, but it's going to help me get my answer. Let's solve for this height. So cleaning it up a little bit, we have 36h, 6 times 6. Now, I can divide by, or just do the Lynch swap, either way, divide by 36 pi. This would cancel, divide by 36 pi. Notice I could move that down to the bottom. So h is equal to 226 divided by 36 pi. And I'm going to round anyway, so let's turn this into a decimal. So 226 divided by 36 divided by pi, I get 1.998. So almost 2 inches high. And that looks the same. If this is 2 inches, that's 6 inches. That looks about right. Now I want to fit 16 of these. So I have to divide by 16 to get my final answer. So divide by 16 and I get 0.125. Now this number actually means something in real life. That is a fraction. 1 divided by 8, yeah, it's the fraction 1/8. And if you go to Home Depot, you can get a saw blade that's 1/8 of an inch thick. So that's actually true to life. This is a real life type of problem. They've asked us to round to the nearest 3 decimal places, and that's what we've done. Okay, last question. A candle maker adds lemon oil to wax to make a lemon scented candle. How many ounces of oil would he need to have 0.0025 ounces of oil per cubic centimeter of? So he needs this many ounces per 1 cubic centimeter. Okay. So how many ounces would he need? So we need our answer in ounces. So notice, to get our answer, we need these centimeters squared to cancel so that our answer is in ounces. So in order to do that, we need to multiply, not divide, by our volume, because our volume will be in centimeters cubed. Did I say squared? I meant cubed. Cubic centimeters, also pronounced centimeters cubed. So let's figure that out. We know that, right? The area of anything in the universe is the area of that base times however high you stacked it. So that's going to be base times width times height. So 10 times 8 times 25. Okay. So that's 2,000. That's the volume. And I have this many ounces per each 1 centimeter cubed, notice this will cancel and leave us with our answer in ounces. So that's exactly what we wanted. So 2,000 times 0.0025, we get 5 ounces, and that number makes sense. Look on the side of a candle, figure out how many ounces. That is a number that completely makes sense. Take care, guys.